Let's move me a little bit. Okay, let's talk about systems. So we talked about the kind of three interrelated themes that really kind of drive the whole class, the whole semester. Plate tectonics, evolution, and geologic time. So how are those all connected? Well, they're all connected because Earth is a series of systems. In fact, a system is defined as really anything you define it as. The universe we can consider a system and all its moving parts. We can focus on just the galaxy, the Milky Way galaxy as a system. We can focus on just our solar system as a system. We can focus on just Earth as a system. So a system is defined however you want it. But since this is a geology class focusing on Earth, we'll focus on these systems of Earth. So Earth is a system of itself, and it has interconnected subsystems. And there's kind of four of them. And they all have the word sphere in them. So we have the atmosphere, air and the gases in it. The hydrosphere, water, fresh water, salt water of the oceans, glaciers. The biosphere, all the living stuff, plants and animals. And then we have the lithosphere, and that's the Earth's rocky surface. Now, the lithosphere is actually driven by kind of what's happening below Earth, or below the surface of the Earth, below the crust and the mantle and the core. But it's really those four spheres that are those subsystems that are kind of all connected that drive Earth as a system. And as you can see, they're all interconnected and they all play a part. And so we have the lithosphere, that's the outer crust of the Earth, and that's really driven by, again, what's happening in the mantle and core, these different layers of the Earth, which we will get to momentarily in a different section, but how the surface of the Earth plays a part in the biosphere and the hydrosphere and the atmosphere. It's all interconnected. So the Earth is a system. Hell, science is a system. Typically, the way it's taught in high school, which is where most people are exposed to a number of different sciences first, is incorrect. Most high schools teach it, freshman year you're doing like biology, maybe sophomore year you're doing chemistry or something like that, and maybe your junior year you're doing environmental science or physics or something else. That's kind of backwards. All right. The way the system of science should work is the foundation of science is physics. I'm not expecting you to know any physics, but I'm just saying the foundation of science is physics, because you need physics to explain chemistry. You need physics and chemistry to explain biology. You need physics, chemistry, biology, meteorology, climatology, the study of weather and climate, to really understand geology, because all of those things play a part. I'm not expecting you know any physics, you know any chemistry, you know any biology, you know any of that stuff. What we will need to know to get a better understanding of Earth, I will kind of give to you in as simple as terms as possible. And I would never really test you on anything super crazy like physics or chemistry, anything like that. But it does play a part. We do have to have a basic understanding of that stuff. So science is a system, Earth is a system. There's parts that go into that, whether we like it or not. But I will present it in a way that's informative, hopefully entertaining, but also enlightening. So just another visual of kind of the systems and how they all interact. These are all subsystems. We can look at just the geosphere or the lithosphere. That's the Earth's surface. We can look at just the hydrosphere as a system. We can look at just the biosphere as a system. We can look at just the atmosphere as a system. Or we can look at how all of these interact to make Earth what it is, what it was, and what it will be in the future. And that's what we're going to do here. Okay? Now, before we end this video, because this is section 2, just a short little one, just to kind of get you in this idea of how things are all connected, I want to mention this, all right? You need to watch these videos. Watch and listen, right? As I mentioned in the first video, just let it soak in, see what happens. The The best way that I can ensure that you do that, because that's going to set you up for success in this class. There's a very easy way where some students could just not watch these videos and try to progress through the class. Ain't happening. You need to kind of be exposed to this stuff. Not that you're going to memorize all of this stuff, but I want to ensure that you at least watched and listened to that and you've been exposed to the material. So when it gets into laboratory exercises, future units, and tests, at least I can ensure, yep, you've been exposed to this. The way I'm going to do that is with something called the super secret code. In these random series of videos for each unit, I will give you a series of numbers. It could be 1, 2, 7 different numbers. Sometimes letters. Sometimes I tell you to do things with the code, maybe something mathematical, or flip the code around. Because you're going to need that code to answer the question or questions that come at the end of this lecture. Okay? More on that, what comes at the end in a later video. But again, the super secret code. Now, this is the best way that I can ensure that students are at least being exposed to this material. You'll never know which video or videos I'll give the code. Sometimes I give it all in one video. Sometimes I spread it out over a number of different videos. But I'm kind of hiding this code, and I will tell you the code. Either I will say it or I will somehow show it on the screen. All right, so that ensures that you need to be watching and listening, because I've had some students in the past say, "Oh yeah, I just put these on my earbuds and I listen while I'm cleaning." Well, if you're only listening, you're missing the visual part of this, so that's no good. Or I just have it on, but I have it on mute. Then you're missing me elaborate on something. So the best way that I can ensure you're being exposed to this material is if you're watching and listening. And by embedding these super secret codes in random videos, that's the best way I can ensure, that you're trying to watch these things. Some people find it really annoying. I get it, right? I get it. Other professors might use, questions throughout the lecture, blah, blah, blah. I don't know. That's kind of boring to me. I'm not interested in that kind of stuff. So I just want to make sure you're exposed to it, the material. Not that you fully understand it after you watch all the videos in a unit, but at least you've been exposed to it. All right. So by kind of hiding the super secret code by either me saying something or me showing you a number or numbers, then that's the best way I could come up with for you to be exposed to this material, to ensure that you're watching this. Because if you don't have that code, you can't answer the question. All right. And I really dislike getting those emails. What's the code? I don't know. Watch the videos. Well, I have to watch. Yeah, that's the purpose of these lecture videos. You're required to do this. This is a lecture and lab, a 4-credit-hour class. You got to watch these things. All right. Some people watch these on kind of a faster speed. You can do that in YouTube. Again, instead of just watching it in Canvas, if you pull these up in YouTube, you can change the speed. Some people can fully watch it on a little bit faster speed and let things soak in. Some people need to watch it at regular speed, which I usually recommend. Sometimes I talk a little fast. So if you're watching this on faster mode, 1.5 times speed or however that works, then I'll be talking real fast, and you might miss some things. Some people can do that. Some people can't. But in any case, the super secret code, I'm not trying to be a butthole. I'm not trying to be, haha, I'm going to get you. I'm not trying to hide these codes because I'm evil. I just want to make sure you're exposed to this material in a proper way. All right? Because it's only going to benefit you in the long run. So many things in life, we try to find shortcuts to get it done real quick. But when we do that, things get messed up. So if we just slow things down and kind of get a better understanding, when we go on to the next thing, we can get it done and get it done better the first time. If you're just kind of flying through these videos to get the code so you can get on to the, so you can get on to the, the next thing, you're going to miss aspects. You're not going to do as well on the lab, and you're going to miss some points, and things are going to stack up, and the grade's going to, decrease rapidly. All right, so this is for your benefit. Again, a lot of the feedback that I get is that, oh, these codes suck. I hate them so much. I get it, all right? because you're looking for a way to kind of cheat the system and get through and get things done real quick. I get it. All right. Just slow things down. Watch them. Let it sink in. Watch and listen. If you're doing that, when I give you the code, you're like, oh yeah, and just jot it down real quick. All right. So anyway, that's an aspect of these lectures. It's the best way I can ensure that you're watching all of these videos. If for some reason that you, after you watch all the videos, you go to input the code and answer the question or questions that come at the end of these lectures, and you are unable to, it says the code's not working, then you miss something. My first suggestion will always be, if you email me, hey, the code's not working, I'm going to just tell you, hey, watch the videos again. You missed something. Watch them again. All of them? Yeah, I don't know. Watch them all again. However, if you're like, I'm just making this up. Let's say the code is, this isn't the code for this one. I'm just giving you an example. Let's say you watch all the videos and you think the code is 1, 2, 3, 4, 5. You're like, hey, I watched the videos and I thought the code was 1, 2, 3, 4, 5. Again, this is just an example. Am I missing something? That I can work with. I can be like, hey, yeah, you know what? Maybe you want to watch this other video. I think you missed something in there. Hey, go back and watch the section 6 video. You missed something in there, or something like that, right? Don't just say, hey, the code isn't working, because I'm going to say, hey, watch the videos again. Again, I'm not trying to be a butthole. I just want to set you up for success. Watching and listening and letting these things soak in, I think is the best way to do it. Again, whether or not you take notes, again, that's up to you. The best way I can ensure you're being exposed to this material is by embedding those super secret codes. So if you're just watching and listening, the codes will appear. All right. Again, sometimes I say them. Sometimes I just continue to talk about geology, and I might hold up a little sign that has numbers on them. So that's why you got to watch and listen, because I could be saying something. If you're only listening to this and you're not watching it, you're doing chores, right? I could be talking about geology, then all of a sudden I'm holding up something, and you go back to watch the video, you missed it. So watch and listen. That's why I break these up into smaller chunks, so you can just take one at a time. You don't have to sit here and sit through a whole hour, hour and a half, 2 hours worth of stuff. Digestible little chunks. Okay? Anyway, that's a lot of blabbing about the super secret code, but again, I want to set you up for success here and in life. So, we'll pause here, and when we come back, we'll continue on to the next section, kind of getting into a brief description on the science of historical geology. I'll see you then.